Alright guys, I'm going to go through the video explanations. I'm just going to recap some things because I know we have some people absent and we have some schedule changing. So here's your table of contents. Just pause, you know what to do. Rewind, fast forward if you need to, if you have the information down. So starting our table of contents, you'll get some more information tomorrow, especially the guided practice. That's what we did in class for some of you, and then this was posted on Edmodo. There is a partial key. So I just kind of put examples of what I posted on Moto. Here I even marked or stated that the markings can vary. We did a square, but don't worry about that. It's not in there. You'll see it again. We had talked about always, sometimes never. Remember, we up the flow chart. That's always. Did this on our yellow flow chart in Unit 6. And here's our key concept I asked you to memorize. You can also use Pythagorean theorem. We talked about classifying a triangle by its sides. And so to do that, we have to use a distance formula. Or you can use Pythagorean theorem. So we did this one in class. I went through the steps, kind of see what I did here, showing you me plugging in the actual coordinates, and then comparing our answers. So once I got an answer, I went and labeled it on the graph so I can see it. But basically, since AB and AC both for 5, the two sides are congruent, then by definition this was isosceles. And we talked about simple U2, and I'm going to move this up. To use these steps, watch this video right here if you needed to complete this problem to determine what type of triangle it is. Now, I see that my copy cut off, so this should have been DE. I think seeing the rise over run and using the change in the y and the change of x, the vertical and horizontal distance, is easier. And I'm going to do it all in one step because Pythagorean theorem, and I'm just kind of just a little side note, sidebar. Pythagorean theorem is a squared plus b squared equals c squared. Every time we're trying to find this bad boy right here, but we have to find the c. So to get to just the c, I have to take the square root. Well, whatever I do to one side, I do to the other. So basically, I'm always taking the square root of a squared plus b squared to get to my c. So that's my little shortcut because I'm using my rise over run to do that. My vertical distance and my horizontal distance. Now you don't have to literally draw that. I know you can count and just physically see that. So we have, but you do need to show what's going into our radical. So we have underneath our square root, our vertical distance, and your A and B can be intertwined. So I have 4 and 1, I believe. Yeah. So this would be 4 squared plus 1 squared, and then we're going to simplify that. So this comes out to be the square root of 17. Okay. So I'm going to do the same thing with EF. All in one swoop. Using our rise over run, our vertical distance 2 or horizontal, even though we're going to the left. We're still going to use our positive because distance is always positive. So we have, I think, 2, 4. Yeah. So 2 squared plus 4 squared. That gets simplified to 4 and 16, which I already know, is square root of 20. Now, yes, we can simplify that. 4 and 5, square root of 4 is 2. So 2 square root of 5. But I just want to pay attention to our radicals because we got to see if we have the same radical. Determine what if we at least have isosceles. So DF, I'm doing the same thing. We're doing our rise and run. Now we have a 2 here. So our rise is 2. So 2 squared. Our run, oh, this one's 5. So that's going to give me a different number here. So I have 4 and 25. So we have the square root of 29. So physically, I'm just going to write down our calculations. Square root of 17 is not the same thing as the square root of 20, which is not the same thing as the square root of 29. Since all of these are not the same, we should have seen that this was scaling. Okay, this is scaling. Now, I think I asked you to try this on the multiple choice type of question. And here's your video explanation if you want to check your answer. The answer was, before we get to that, I went ahead and started to show the same ratios. I just kind of want to show you right here. If I'm looking at R to S, how's the ratio, the change in Y over change in X? Has, I believe, 2, 7. Remember, If I'm looking at my distance, I'm always using the square root of those numbers, right? Well, if I look at ST, change in Y, change in Y is, yeah, and over change of X. Yes, we have -7, and we have a -2, which ends up being a positive. But remember, we're always using the same number. So a -7 squared is just going to end up being positive. -7 to negative is positive. A -2 squared is just going to end up being positive because really we have the same number. So if you have the same ratio, using the same numbers, automatically we should see that those two are the same. Just looking at the slopes, they have the same numbers in the ratio. Um, they are opposites of each other, so that's how we have an intersection here. Or no, they're not. They're just meeting at S. Now, I'm going to do the slope of RT. Just check that one. But I can say right now it's not the same as that. Well, I'm hoping you can see because this one is 1, 2, 3, 4, and I'm doing 2, 7 every time. So our answer was isosceles. Okay, so that takes care of that multiple choice. Excuse me. Now, I gave you the steps here. I literally went through this problem. I wanted you to kind of see if you can follow my work. We are using our slopes again. I'm just counting the rise over run, and then I'm comparing them. Okay. And then I did the same thing for the diagonals. Look at the slopes. Now I did this lowercase m to show the symbol for slope. And so I'm hopefully you see that the opposite. We have some same slopes here. These two were the same. Sorry. So that means they're parallel and they're opposite each other. Yeah. Okay. So this is what I needed you to do to check to see if you got it. Using those same previous steps, can we determine if this is a rectangle and explain it based on our results on our slopes and our distances? So I think I can minimize this just a little bit. There we go. Yeah, it's a little bit better. Now, calculate your slopes. M to N, our slope we have is positive 1 and -1. So 3 over -1. Oops. Fix that. So you have 3 over -1. N to P is 1, positive 3. M to Q is also 1, positive 3. And P to Q is down 3, so that's -3 to the right 1, which is positive 1, but those are both end up going to be a negative. So I'm hoping you see that we have at least parallel slopes. So, and that was MN and PQ. So we have opposite sides parallel, both pairs. So we at least have a rectangle does have that. But what makes it a rectangle? For it to be a rectangle, we have to have 4 right angles. So we're thinking about perpendicular. So now I need to compare consecutive sides. MN to NP. Look at those two sides. I'm looking at these two slopes. They are opposite reciprocals. So that proves that they are perpendicular. So I'm going to put that box in there. So if I have a parallelogram with 4 right angles, and that happens for consecutive sides, then I have a rectangle. Okay, so I have justified that. You could also look at the diagonals. Okay, so you could also look at your diagonals to justify that as well. And that is in our next part. But if our diagonals are bisecting each other, and if they're congruent, having the same slope, which I could see, because right here I can see I can count my rise over run is the same for each one. You'll see the right triangle there. Yeah. All right. So just make sure you have your slopes to work to justify your answer. Now on problem 3, I gave you your 2 methods that we're going to use. One is the distance formula, or the Pythagorean theorem, which we've done on our first 2 problems, problem 1 and the got it. So go ahead and just use can do the distance formula or your rise or run or our one shot kind of attack. So we should have here 1 squared plus 3 squared, oops, to find that distance. And then we're going to do the same thing with PQ. And we have 3 and 3. Yeah, 3 squared plus 3 squared. And then in R, we have 3 squared plus 3 squared. And then QR is 1 and 3 again. So since I see the same numbers in each and I simplify them, I'm going to have the same thing. So we have square root of 10, square root of 10, okay, and then we have square root of 18. So because opposite sides are congruent, then you have proven without using the slopes of those sides that you have a parallelogram. Okay. Method 2 is looking at the midpoint. So here we're going to use the midpoint formula for each diagonal because we're going from N to Q. And our midpoint formula um, is basically just our averages of our coordinates, x1 plus x2 divided by 2, and our y1 plus y2 divided by 2. Well, we're going to check that for each diagonal. So really, I'm just going to have NQ is the x's are -5 plus 1, I believe, yeah. And then our y's are 2 and 0, which this gets simplified to the order pair -2, 1. Now, we're going to do the same thing for the other diagonal, which is PR. Our x's are our -2, and I think, yeah, -2 divided by 2. And we have the 3 and a -1. Again, we get -2, 1. That means that if they have the same midpoint, they have the same, that midpoint bisects. So they're bisectors for each other. Okay? And we have a theorem that states that, or one of the facts to a parallelogram is that if the diagonals bisect each other, then the parallelogram, quadrilateral, but then it proves that the quadrilateral we have is a parallelogram. So if it's a parallelogram, the opposite sides are parallel. Okay, so if this is the same, then therefore we have a bisector. We have and that was for our perpendiculars, or for our diagonals. Okay. Now, this is the check for understanding part that I wanted you to do. I think, you will receive copies of this, but you are going to have to cut and paste. There's going to be like a total of, I think, 6 problems. We'll go over those. We'll get started with those in class, but you will finish it. It will be kind of like an exit ticket. And so if you just wanted to look at them, see if you have an idea of what to do, you can do that. Or if you already know which ones you want to ask questions about, you can do that as well. There's a couple challenging ones here. But thank you for taking your notes. And there will be a video helping you with the homework too as well. Be good.